All right, so we are looking at exponential functions. This is your review. On this first part, we're solving exponential equations. So you're wanting to get the bases the same is our strategy for this. So since these bases are already the same, then they just cancel each other out because I have 1 on each side. So 2x minus 1 equals x plus 2. And then I'm just solving for x. So subtract x and add 1. So x equals 3. Here, my bases are not the same, so I can't cancel them out. So I can rewrite this 4 as 2 squared. So I have 3x here, and then 4, again, is 2 times 2. So I could rewrite that as 2 squared, but I still have that x plus 2 as the power. And so then I have, now the bases are the same, so those go away. So I get 3x equals 2 times x plus 2. So we're multiplying that power that I wrote and the old power. And then distribute through 2. So I have 3x equals 2x plus 4. And then subtract 2x. So x equals 4. Same strategy here, but we're going to have to do both of these. So I could rewrite 4 as 2 squared. And I can rewrite 8 as 2 to the third. And again, if you're not sure, you can always factor it to see that that is 2 to the third because there's 3 2's there. So times 4x minus 3. And then now bases are the same, so then I can do 2 times 2x minus 7 equals 3 times 4x minus 3. So then I distribute my 2, I get 4x minus 14 equals 12x minus 9. Subtract, write this over here, 4x minus 14 equals 12x minus 9. Subtract 4x on both sides. Negative 14 equals 8x minus 9, and then add 9. So I have negative 5 equals 8x, and divide by 8. I'm running out of room. So x equals negative 5/8. All right, so this can be rewritten as 7 to the negative 2, because 49 is 7 squared, and when I bring it up, it makes my power negative, so that's where we get that negative 2. And you're going to want to remember that for the test, because you do have one like that. Then once bases are the same, I can rewrite my power, or can cancel those out, and then negative 2 times 3x minus 6 equals 2x minus 1. And then distribute out my negative 2 to both, so negative 6x equals, or plus 12 equals 2x minus 1. Subtract 2x here, and I'm going to subtract 12 this way then. So I get negative 8x equals a negative 13. So I divide by negative 8, and x equals 13 over 8. Inequalities work the very same way as equalities, except for we have inequalities, so if we divide or multiply by negative, we need to remember to change my signs. So I have 32, which can be written as 2 to the 5th. Again, you can just break that down into factors if you're not sure what the power is. So I rewrite that as 2 to the 5th. And then 128 can be written as 2 to the 7th, I believe. So I have 1, 2, 3, 4, 5, 6, 7. So is greater than 2 to the 7th times 4x plus 3. And then again, once bases are the same, they cancel. I'm going to distribute my 5 there, so I get 15x minus 20 is greater than 28x plus 21. And then subtract 15x and subtract 21. So I get negative 41 is greater than 13x, and then divide by 13. So negative 41 is greater than negative 41 over 13 is greater than x, so x is less than negative 41 over 13. Same thing here, rewrite these so that my powers are the same, so rewrite 27 as 3 cubed. And rewrite 9, since it's 1/9 as 3 to the negative 2, because that was a fraction, and again, same thing, once that's a fraction, that's a negative power. So those cancel out, distribute my 3, so I have 6x minus 5 is less than negative 10x. I'm going to subtract 6x here. So I have negative 5 is less than negative 16x. And then, this should be 15. So negative 15. And then divide by negative 16. Since I divided by a negative, I'm going to flip my inequality. So I have 15 over 16 is greater than x, or x is less than 15/16. All right, so on this one, it is, move that into the screen, this is where we're writing our equation. So remember, your equation is y equals a times b to the x. So your first point, 2,000, is your 0 or your a. 6 in the year 2000, 6,071,675,206. So that's my first, and this is a. And then my b, I have to find, but I do have this data. I have 2008, which is 8 years. It was 6,679,493,893. So this is going to be my x, and this is my y. So just any x and y, and again, a is here. So I can plug all of that in here, and I'm going to solve for b. So I'm going to put the 6,679,493,893 in for y, 6,071,675,206 in for a. Again, b I don't know, but I know that one of my x's is 8, and then I'm going to solve for b. So divide those two. And I'm not doing it in my head. I know, shocker. So I get 1.1001, and I'm going to go out 4 decimal places. Get used to that on this test. So then I'm going to take the 8th root of that. So on the calculators, the yellow calculators, you can do 8 and then math 5 to do 8th root, or you could take it to the 1/8 root, but you should get b equals 1.01. So then my equation, which is what I'm trying to write, so don't forget that part. Some of you did all this work and then didn't get this part written out. So there's my a, and my b is 1.01. These cannot be multiplied. This is exactly all I would want on that. All right, then we went into logarithms. So writing in exponential form, so 3 to the 5th equals 243. So you always start at your base. Base here is 4. 4 to the 3rd equals 64. Again, these should be true when you write it. So if you want to check it, 3 to the 5th should give you 243 if you wrote it right. And then when I'm in logarithm or in exponential form, this is my base. Again, we start at the base always. So it'd be log base 8. And that 8 is smaller of 164 is, and I'm going to put it like this, That is not a power, so make sure you don't write that as a power because you do lose some points for that. Equals -2. So here's my base of 1/9. So I do log base 1/3. Make that smaller of 1/9. That should be regular size equals 2. Picky, I know, but it's a total different equation if I write it like a power. And then solving logs, if I have a log on both sides like these two, then they just cancel out. And I get 3 minus x equals 5x minus 15. So I'm going to add x here, and I'm going to add 15 the other way. So 18 equals 6x, and then divide by 6. So x equals 3. And if you need to at any time, pause the video. I'm just kind of moving right along because I want to make sure that we cover these all. All right, and then log 81, both cancel out except 1 on each side. So I have x plus 20 equals 6x, and then subtract x. 20 equals 5x, and then divide by 5. So x equals 4. Right, and then we had, let's see if I put this, okay. On the test, the common log and the natural log will be combined, and that will be covered on the review for tomorrow. But on this one, I want to rewrite. Notice it says use these, so you have to use those, and your work is the only way to show that. If you don't show me your work and you have the answer, it won't be counted, so make sure you use those. So I'm going to rewrite this as multiplication. So log 2 of 5 times 5. Then multiplication in log is addition. This is property of logs. So I want you to show me you understand property of logs. So I would rewrite this as log base 2 of 5, this 5, plus log base 2 of 5. And then I can substitute this in for log base 2 of 5. So 2.3219 plus 2.3219. And then I add those two. And I should get 4.6438. Very important that you show this step, because otherwise you will not get 4 points, and that will hurt your grade. All right, and then here we have a division problem. I don't need a factor. I'm just going to rewrite that as a subtraction problem. So log base 2, 3 minus log base 2, 5. And then once it's in log base 2, 3, and 5, I grab these, so 1.5850 minus 2.3219. And I get negative 0.7369. Very, very important, again, that you write it. I keep saying this because I know someone's going to just give me these numbers, and they're going to be frustrated that they lost 4 points on that. All right, so, and then here's solving. I can't cancel these logs out because of this 3, so I got to move it. So I'm going to move them to a power. So then I have log base 10, 27 equals log base 10 of x cubed. Now I have one log on each side, so they cancel out. So 27 equals x cubed, and then cubed root both sides to get this x by itself, and you should get x equals 3. Do one more. Again, I can't cancel these logs out because I only can do that if there's one log on each side and just the log and not numbers outside. So this is a problem on this side, this part. So I have to rewrite that as one log, and addition is multiplication. So I can rewrite it as log base 4 of 5x equals log base 4 of 60. Then I can cancel them out because nothing outside the logs, only the logs on each side. So 5x equals 60, and x equals 12 when I divide both sides by 5. All right, I'm going to finish this up on the next video tomorrow.